So hey guys, in this video, first we will going to cover the remaining examples of the previous lecture and then we move forward. So starting from the examples, if we have these three molecules and we have to find out whether the lone pair are in resonance or not. So what we have to do, first we have to try to make its orbital picture. As I told you, we have to find out whether these lone pairs of electrons are in resonance or not. On the basis of that, we can calculate its hybridization, whether it's sp3, whether it's sp2 or sp. So first make its molecular picture. So as we can see in this example, there is no adjacent p orbital adjacent to nitrogen. There is no p orbital. That's why these lone pairs of electron cannot participate in resonance. We can directly say that lone pairs are localized and present in hybrid orbital. We will see in which hybrid orbital. So if we have to calculate its hybridization, what we have to do, we have to calculate number of sigma bond plus localized lone pair. As we can see, there is one localized lone pair and number of sigma bond 1, 2, 3. So summation comes as 3 sigma bond plus 1 localized lone pair. It comes as 4. It means the nitrogen is sp3 hybridized. So the hybridization of nitrogen is sp3. Clear? And the lone pair present in sp3 hybrid orbital. sp3 hybrid orbital. Let us move to second example. So if we have to calculate this hybridization, first we have to see whether the lone pair participate in resonance or not. So as we can see that these lone pairs are in resonance. First try to make its molecular picture, then it will be more clear to you. And the pi bond is formed between these two carbons. So p orbitals will be used. If this is px, it will be px and pi bond is formed. And this lone pair is present in px orbital. So the plane of p orbital and the lone pair is matched. So this can be transferred from here to here. So this is delocalized lone pair and participate in resonance. So if we have to calculate this hybridization, number of sigma bond plus localized lone pair will come as number of sigma bond 1, 2, 3 and number of localized lone pair 0. So it is sp2 hybridized. Let us come to third example. In this case, pi bond formed between these two atoms, nitrogen and carbon. So if px of this nitrogen is forming the pi bond, so px of this carbon will take part in forming pi bond. So if px orbital participate in forming a pi bond, the lone pair will be present in either in py, either in pz. So in this case, as we can see that the plane of both the p orbital are not matched, as this is py and pz and this is px. So the planes are mismatched. So lone pair is localized and cannot participate in resonance. And if we have to calculate this hybridization, what it comes, number of sigma bond 1 and 2, because this is pi bond, not sigma. This is sigma and this is pi. 1 and 2, 2 sigma bond plus 1 localized lone pair. It comes as 3 and hybridization will be sp2. So in this way we can find the hybridization and the number of pi bond in a given molecule. If we have given this compound and we have to calculate the hybridization of nitrogen, so for that, first we have to see whether this lone pair is participating in resonance or not. According to that, we have to put the value in number of sigma bond plus localized lone pair, and this summation tells us the hybridization of our atom in a molecule. So first make its molecular picture. As the pi bond is forming between these two atoms, so the px of this carbon and px of this carbon will form pi bond by side by overlapping. And again we have a single bond, and again the pi bond is forming between carbon and nitrogen. So again px of this orbital, px of this atom, and px of this nitrogen will form a pi bond. And if px of this nitrogen is used in forming a pi bond, so our lone pair must be in py or either pz. So our lone pair is in py or in pz. So as we can see that the adjacent orbital is px, but our lone pair is in py and pz. So the planes are mismatched. Plane are mismatched. That's why the lone pair cannot participate in resonance, and this lone pair will be called as a localized lone pair. So if we have to calculate this hybridization, but it comes number of sigma bond, one with hydrogen and another with carbon, 2 sigma bond plus one localized lone pair. The summation tells us hybridization is sp2. Clear? Again, have a look on another example. Pause the video and try to solve this. Predict what will be the hybridization of this nitrogen. So again, we do the same approach. First we have to draw its molecular picture. So make this pi bond is forming between these two carbons. So px of this carbon and px of this carbon is forming a pi bond. Again, another pi bond is forming between this carbon and this nitrogen. As we can see that px orbital is already used in forming a pi bond. So the another pi bond will be formed by py orbital. So py and py of this carbon will form another pi bond. As py orbital is used in forming a pi bond between this carbon and this nitrogen, so the lone pair over nitrogen will be present in px, because px is not used in px orbital, not used in uh, forming a pi bond. So px orbital has lone pair. So as we can see that the adjacent carbon has px orbital, and this lone pair also present in px orbital. So the resonance is possible in this scenario, in this case. So this lone pair will shift in p orbital of this pi bond, and this pi bond shift here. So the resonating structure CH2 C triple bond NH, positive charge, negative charge. So this will be the resonating structure, and this lone pair is delocalized. If we are interested in finding the hybridization of this nitrogen, it will come as number of sigma bonds are 2 plus localized lone pairs are 0. So the summation tells us the hybridization of the nitrogen is sp. So in this manner, you can solve any of the problem related to resonance and hybridization. Let us have a look on a question related to this concept. So we have a two molecule and we have to predict in which molecule the rate of protonation is higher and in which the rate of protonation is lower. So first have a look on the question, rate of protonation. This type of question you will find in your examination, in your IIT JEE NEET examination. The name of this molecule is pyrrole, and another we have pyridine, 1 mole H plus. So in which case the rate of protonation is higher. As we can see that the lone pair over here and lone pair over here, this lone pair is delocalized, and this lone pair is localized. Localized lone pair always abstract proton faster. So the rate of protonation will be higher in case of second. So the K2 will be always greater than K1, because in second case the lone pair is localized, so it will be more available for proton to be attacked, and in the first case the lone pair is delocalizing throughout the molecule, and that's why the proton cannot attack at a faster rate. So K2 will be higher as compared to K1. Let us have a look on a second question on this concept. If we have a molecule, I hope till now you are able to find out the which lone pair is localized and which is not, because these questions are totally based on the concept we did till yet. So if we have a 1 mole of H plus, so you tell me the proton will attack on which of the lone pair. Let us suppose this is A and this nitrogen will be represented by a B. So you tell me which of the lone pair will attack on proton out of these two lone pairs. So apply the same concept. As you can see, this lone pair is not localized. This is delocalized. This is delocalized. Delocalizing here and here. And this lone pair is localized. So localized lone pair always takes proton at a faster rate. So the product of the given reaction will be NH, and it will bear a positive charge. So rather than attacking on this lone pair, the proton will goes to the this lone pair because it is localized. By remembering this single line, you will be able to give the answer of variety of questions related to this concept. Now let us have a look on carbonyl compound. If we have to predict the hybridization of this oxygen, what we have to do? In the same way, first we have to draw its orbital picture. As we know, the pi bond is forming between these two atoms. So if px is used, so px of this oxygen would form pi bond. So as we know, it has two lone pairs. So one will present in py and another will be in pz. So now again the plane of both the p orbital, one which have lone pair and another onto which it has to be transferred, are not in same plane. The planes are mismatched. The planes are mismatched. Planes are mismatched. The lone pair, the lone pairs are in py and pz orbital, and the adjacent orbital we have is px. So the planes are mismatched. So both the lone pairs are localized. Both the lone pairs are localized. If we have to calculate the hybridization of this oxygen, it will come as 1 sigma bond, 1 pi bond. So number of sigma bonds are 1, and we have two localized lone pair. So it will come as 3. It will come as 3, and the hybridization will be sp2. So in this way you can solve the variety of questions. In next lecture we will dealing with negative charge and pi bond resonance. So till then, take care. Bye bye.